Famously, coal has problems. I've hinted at a couple of them. We're going to highlight a few specific problems, issues with the coal world. The first one that we're going to talk about actually has to do with the fact that coal isn't just this kind of self-contained rock. It has a lot of volatiles in it, which that's a kind of fancy term for things that are like gases or fluids that are contained. So it's not just the cellulose organic material. It actually, in many cases, has some plankton in it, right? So some fatty acids as well, usually at a much lower percentage, meaning that there can actually be an organic content of fats in this coal that will turn to basically oil, although it's a fairly low percentage. Again, in one of your readings you may have kind of heard a little bit about coal oil. So it exists, but it's not a primary source of oil. But kind of thinking back to oil and how that whole system works, remember the lightest components of crude oil are gases, right? The ones that in our fractionation column were coming off the top, right? The lightest being methane, propane I think was the second, heptane maybe is the third, and then butane is the fourth. But so anyways, if we were to go in here and dig ourselves our tunnel, again kind of imagining ourselves in Victorian England, being a terrible coal miner, so we put in our coal excavation plan here, right? We're going in to get it. Whether we're doing it in a modern sense or not, it's really kind of irrelevant. But remember, in this coal, there are gases that will kind of flux out of the rocks, right? They'll flow out of the rocks. They're a vapor. So if you're in this coal, this mine always has a little bit of essentially methane and propane and actually CO2 as well that's kind of coming out of the rocks because gases flow essentially down gradients. There's lower concentration. So what this means is that in particular methane is a pretty big problem here. I think in one of your readings, maybe it's your reading this week, so sometimes it's hard for me to imagine because the readings are like a few weeks out and then I'm filming the videos. But I think it's the second coal reading where they talk about choke damp. I really love these terms. Choke damp, which is CO2, and fire damp, which is this gas or this content in the atmosphere that can explode. So methane, which is basically coal gas, so coal gas or methane can pool up in these sorts of things, and if it were to somehow ignite, the whole mine explodes. And actually this happens all the time. There's explosions in coal mines for a couple of different reasons. Methane is the primary one, but you can also get coal dust in the air. So similar to the way that a grain silo can explode if there's enough dust from the grain. But so that's kind of in and of itself, that's a big problem with the extraction. But let's compare that to some of the problems that are associated with actually burning the coal and using it as a power source. Well, I've redrawn our furnace here just to kind of allow us to revisit two of the ways that we're going to talk about problems on the back end. So this material in the bottom of the furnace, that's the solid portion left over. So when the coal burns, actually think about burning a piece of paper, right? So when a piece of paper burns, some portion of that paper goes off into the atmosphere is two different things, as gases that are released, and then also aerosols, which are particulates like the smoke. And then there's the ashy material left behind, right? So you no longer have a piece of paper, but you have a little bit of ash and some stuff that blew away that you're never going to think about again. Maybe you should think about it. We'll see why. So here, we're going to talk about this material, coal ash. So this is all of the other stuff in the coal that was heavy and didn't burn. Famously, one of the minerals that often occurs in the case of coal is iron sulfide, which you've heard of as iron pyrite. So FeS2. So iron sulfide, so it's got a lot of sulfur in it. And when we have this coal ash, that coal maybe had 1% iron sulfide in the beginning, but once all that carbon is combusted, now the percentage of iron sulfide in that coal ash is much higher, right? Because that stuff never burned. It just got more and more and more concentrated. So essentially what we do with this coal ash is we put it in, we do two things with it, right? So we put it in a big wet pond and try to keep it wet so it's like a muddy slop. The reason we keep it wet is so that wind doesn't blow it away. In other cases, we store it dry in big heaps and wind absolutely blows it away. But you can kind of think about this like, if we have it if we just have a big pile of coal ash on the ground, it's like making coffee, right? It's the best analogy, and I think we'll include a YouTube video that has that. So rainwater will fall through that, and water, so iron sulfide plus oxygen plus the pyrite, or the iron sulfide, Fe2, or FeS2, excuse me, is a problem, right? So it turns out it has a very specific chemical reaction that's really common. So iron sulfide will combine with oxygen, so O2. I've got 2 units of it here just to make the stoichiometry work. Here we have another 2 units of H2O, and as a product we actually get this compound. Again, I know that many of you haven't had chemistry, but this compound is sulfuric acid. Obviously we don't want a lot of sulfuric acid hanging around, and again, if we were just to imagine how this would work, in an unmitigated system, you'd have a mound of coal ash, and any rainwater that fell on that would be producing sulfuric acid, which would end up in the groundwater. So we obviously don't allow ourselves to do this. That's why we have an EPA. We generally put them in lined tanks, so we line them with big thick rubber mats and things like that. It's not foolproof. Occasionally these ponds, or these settling ponds, will overflow. There was a case, so again, down in the southeastern United States, we have a lot of coal-fired power plants down in that part of the world. We get a hurricane, right? Hurricane comes through, there goes your coal ash retaining pond, and all that sulfuric acid and all of that coal ash, mud and sludge, ends up in the river. You can see here's an example of that, right? This happens all the time. So these retaining ponds flood, or the walls themselves that are retaining them break for various reasons, and we can get coal ash spills. They're not uncommon at all. So how do you solve the coal ash problem? Well, again, you put it in a pond and hope for the best. Well, that's a short-term solution. There's actually some unique ways to think about it. So there's a company that actually takes coal ash and mixes it with lime, which is derived from limestone, and basically makes cinder blocks out of it. So you can buy coal ash bricks, which is a pretty good solution, right? So you've taken something and essentially made it inert and made a building material out of it. So you haven't really gotten rid of it, you've just made it useful, right, rather than this detriment. So there's an opportunity to make some money in the coal ash world, I guess, if you're not opposed to sulfuric acid. I'm not 100% sure of how they, make sure that stuff's clean in the bricks, but we could maybe look into it. The other big problem that comes from our furnace here, remember I had to kind of change it. This is our furnace at our coal-fired power plant. Is, now that we've talked about the coal ash, we have to talk about the other stuff. So again, envisioning this piece of paper. So when that piece of paper burned, 3 things were produced, right? The ash, which we've already talked about, and then the stuff that comes out the smokestack here. And it comes out in the form of 2 different things. So some of them are gases, and some of them are what we call aerosols. So an aerosol, this is a term we use to describe fine particulate matter. Like, that's where the term aerosol spray, if you imagine a spray, it's taken that fluid and it's aerosoled it by turning it into a lot of little tiny particles that are in the air, or like a spray of aerosol of perfume. So we've got gases that are coming out and particulate matter that's coming out. In the case of the gases, surprise, it's primarily our good old friend CO2, you guessed it. And so a significant portion of CO2 emissions from human beings is actually related to precisely this process, coal power generation. So per megawatt hour or kilowatt hour or per unit energy, or megawatt, kilowatt, just move the decimal. So per megawatt hour produced, coal generates the most CO2 of all power sources. So it's really the dirtiest of the dirty. Remember I showed you that family photo of the three fossil fuels, coal, oil, and natural gas? Well, in CO2 emissions per unit power, coal is number one. And actually, we could even think about different types of coal, right? So, whether we have subbituminous or bituminous or anthracite or lignite, all of those kind of within the coal realm also have different rates of CO2 produced. So that in and of itself is a pretty big problem. We've talked about CO2 wiggles before, so we know that the level of CO2 in the atmosphere, well, the atmosphere is our little warm blanket, right? It protects us. But the amount of heat absorbed and remitted from the atmosphere is directly related to the concentration of CO2 in the atmosphere. So the higher the amount of CO2, the higher the ppm, the more heat is going to come back down to Earth. And actually we've seen, we'll probably look at this diagram a couple of times over the course of this class. The CO2 concentrations since Dave Keeling started measuring these things out at Mauna Loa in 1955, we've increased in that time about 100 ppm. We went from about 310 ppm to 400, and I think we're 412, 413 today. As this video goes in the future, that number is probably going to change.